Can you get it? Is it working? I should click OK that the content is being sent to one or more apps. Have you got the live stream on? Are you recording?
I just started the live stream.
Are you recording?
Yeah. But for some reason, it's not the country, so I mean, I will record. I mean, the recording. Yeah, go ahead and put it on that. I'm gonna start. Okay. And I'll also.
Survey basically says, are you liberal or conservative?
Yeah, I will.
I'm asking you. You're conservative.
Yeah, that's
Yes. Yeah, right out there. So we'll get started with just a moment. Kelsey? Sit up. When did you stop being beaten?
A couple of years ago. I was here for 14 years. So pretty long.
Yeah, that's very long.
Some say too long. Although faculty, you've been doing a good job. I'm really happy there for that long. Everybody was happy. What happened to himself?
The thing about being a dean is supposed to be not doing a good job. Then it's assistant professorship. You have to be a dean if you make it up.
That was presented by some faculty. So I taught the entire time.
Yeah. Yeah.
Well, I developed.
Steve Gaines.
Yeah.
Yeah. He was one of my postdoc advisors.
Oh, good.
He's the only.
So there's the little survey up for anyone who wants to do it now.
You think he's still going?
Yeah, I got you on the end and Andrew here and me here.
Sweet.
Since we're live streaming, I guess we have to start on time.
Yeah, it's true.
No, we won't start till Andrew's back. How about that? Just came in. This is a little pre-meeting survey that one of our sponsors likes you to do. So if you have a second to fill that out, that's great. We'll get started in just a moment. There you go. Okay, let's go ahead and get started. I think I've got to push this back one. My name is James Stoner. It's my privilege to welcome you here, those folks here in person at Louisiana State University and those joining us on the live stream. My name is James Stoner. I am a professor of political science here at LSU and also director of the Eric Vogelin Institute, one of our co-sponsors of the event this evening. Our other sponsors are Heterodox Academy, at least its LSU campus community chapter, and Bridge USA. Heterodox Academy, well, got a slide. Let's see if we go to that. Heterodox Academy is a organization mostly of faculty around the country devoted to open inquiry, viewpoint diversity, and constructive engagement of folks across different points of view. Bridge USA is a student group with a similar mission. They list theirs as involving constructive dialogue, viewpoint diversity again, and solutions to, let's see if I can read, solutions to, can't read my own writing, solutions to political questions. This evening's program will be live streamed on Heterodox Academy's YouTube channel and recorded. We have two speakers representing different viewpoints this evening on our question, energy and the environment, what is the future? Each will speak for 15 minutes. Then we'll have about 15 minutes set aside for dialogue between the two of them. And then we'll open the floor for questions and we'll have about half an hour for that. I'll serve as moderator this evening, but I'd like to introduce the speakers, the president of the chapter of Bridge USA here at LSU, Kelsey Womack. Kelsey.
Hi, everyone. My name is Kelsey. I'm the president of the LSU chapter of Bridge, and I'm a junior studying political communications. So tonight we have joining us Mr. Matt Burgess. He's an assistant professor of economics at the University of Wyoming's College of Business and a presidential fellow in free expression and constructive dialogue. His research focuses on the macroeconomics and political polarization of climate change, as well as mathematical models of human environment systems, natural resource management, and endangered species conservation. Matt is also the host of the Grounded, Not Divided podcast, which fosters thoughtful discussions on important issues, steering away from divisive culture wars and toward real-world solutions. With a background in both ecology and economics, Matt earned his Bachelor of Science from the University of Toronto and his PhD from the University of Minnesota. Before joining the University of Wyoming in 2024, he was an assistant professor of environmental studies at the University of Colorado Boulder. And then we also have Dr. Andrew Dessler, who is a climate scientist and professor in the Department of Atmospheric Sciences at Texas A&M University, where he holds the Retta A. Haynes Chair in Geosciences. He also serves as the director of the Texas Center for Extreme Weather. Dr. Dessler's research spans climate impacts, global climate physics, atmospheric chemistry, and climate change policy. He has authored 2 widely used textbooks on climate change and has contributed to public understanding through op-eds, media appearances, and congressional testimony. A fellow of both the American Geophysical Union and the American Association for the Advancement of Science, Dr. Dessler has received numerous accolades, including the 2021 AGU Climate Communication Prize, the 2014 Louis J. Vuitton Authors Award, and the 2011 Google Science Communication Fellowship. His work continues to bridge scientific research and public policy, aiming to enhance society's resilience to climate change. So we're super excited to hear from both of them. So please give it up for our speakers.
We got lots of wires up here. Professor Dessler is going to lead off. And Sam, if you want to make sure they get the right slides up.
Full screen. Okay. Well, thank you very much. I really appreciate the opportunity to talk to you all about sort of our future of climate and energy on Earth Day, which I didn't realize until I was driving here. So let me begin with, I think this is the only science plot I'm going to show you. The y-axis, the vertical axis, is how much warming we've had since pre-industrial. Okay, so this is how much warming we presently have had, about 2.5 degrees Fahrenheit. I'm going to try to express everything in Fahrenheit. So this is where we are today. We've warmed the climate, the global average warming about 2.5 degrees over pre-industrial, before the Industrial Revolution, when we started burning fossil fuels. This is what we're on track for in 2100, about 5 degrees Fahrenheit of warming. Now, a lot of people look at this, they say, so what? You know, because your intuition is based on your everyday experience. You know, summers are much hotter than winters. You know, 1 week to the next, the temperature can be very different. You look at 5 degrees, you say, this doesn't matter. Now, the problem with that logic is that we're talking here about global average, not local temperature. And so to help me calibrate what 5 degrees of warming means, let's go back to the last glacial maximum. So this is 20,000 years ago. And if you look at it, there are glaciers, thousands of feet thick, over much of North America. There was thousands of feet of ice over Boston, over New York. So much water was locked up in these ice sheets that sea level is 300 feet lower. If you looked at the ecosystems, they looked completely different assemblages of plants and animals. If you walked out your front door in an ice age, you might not recognize the place. So this gives us a yardstick. So anybody know how much colder the ice age was, the global average ice age was, compared to what sort of the modern climate is? Anyone want to take a guess? So it's about 10 degrees Fahrenheit colder. If you cool the global average 10 degrees, you get an ice age. All right. So that puts warming into context. All right. So now I have on here what I will call an ice age unit, which is an amount of warming that we know will radically redefine the surface of the planet. And so this now tells us that what we have already done to the planet is a quarter of an ice age. 2.5 degrees Fahrenheit is a quarter of the 10 degrees Fahrenheit of an ice age. And this is why when you open the headlines, you see this, you know, as you kids would say, shit's getting real. You know, things are happening. Things are happening that didn't happen before, and they are extremely damaging and expensive. So what's more worrying is that we're on track for half of an ice age. All right, 5 degrees Fahrenheit is half of an ice age. Now, let me emphasize a couple of points. As I said, half an ice age is an enormous amount of warming. The students, this is your future, all right? I'm not going to live that long, but you guys are. You're going to live through this. This is not a future generation problem. This is, you know, in 50 years, you're going to, when you're middle age, in 30 years, when you're middle age, you're going to look at this and you're going to say, that guy was right. Because I was right. You probably won't remember anything else about me, but you will remember I was correct. But we still control the future. So that 5 degrees is not yet written in stone. Okay, that will depend on the decisions we make in the next decade or two. Three decades. But if we want to avoid that, we want to start working now. All right. Now, you often hear people say, humans have always adapted to climate change. What's the big deal? The climate's going to change. We'll deal with it. All right, so let's talk about that for a bit. So the first thing is the number one way in the past, over the hundreds of thousands of years of humanity, that people have adapted to climate change is they've started walking, they've gone somewhere else, they've migrated. So, you know, if you live in a region and it stops raining, you pick up your pile of sticks that you own and you start walking. And a couple months later, you get to a green valley and you say, let's build here. So that's the way over most of humanity we dealt with climate change and the climate change impacts. Now, that's not something that people will accept now. Migration is a politically impossible thing. So we can already eliminate the number one way that humans have always adapted to these kinds of changes. You know, we're not going to open up our southern border and let Central Americans come into the US. If Central America gets too hot to farm, water shortages, things like that, that's not going to happen. So number one, no migration. Number two, so you might say, well, okay, let's stop talking about migration. Let's talk about building infrastructure so people don't have to move. So for example, seawalls. So seawall, that's a great way to battle sea level rise, storm surge, things like that. So let me give you one example of how hard this is going to be. So some of you may remember Hurricane Ike, 2008, very near miss on Houston, hit Galveston. It missed, it was very close to sending 20 feet of water up Galveston Bay into the Houston Ship Channel, which would have been, there's somebody, I think it's at LSU, who said that would have been America's Chernobyl. And, it's a good idea to avoid America's Chernobyl. So shortly after Hurricane Ike hit, they decided to build a seawall, which they call the Ike Dike. Now, that was 17 years ago, and it's a $50 billion project, and they've done nothing on it because no one will agree to pay for it. They can't figure out who's going to pay. Now, $50 billion for the US with a $20 trillion GDP, it's not a lot of money. It's a 0.2% of our GDP, but we still can't build it. There's just no consensus to build it. And so when people say, well, we'll build seawalls for sea level rise, look around. We're not doing the things that we should be doing. So what are we doing? Because things are changing. And what's happening is we now blame the victim when people are harmed by climate change. Let me give you one example. So about 2/3 of Texas prisoners don't have air conditioning, have no access to air conditioning. Now, imagine being locked in a concrete box when it's 100 degrees or 100 degrees if you're lucky in August in Texas with no air conditioning. As the headline says, inmates are being cooked to death. Now, we know how to fix this. Air conditioning, it's not rocket science. But of course, no, they don't want to pay for it. The Texas state government, there was a bill, I don't know if there's a bill this year. In 2023, there was a bill. It didn't even get to the government. It's just like, we're not going to do this. And so, what's the rationalization? Well, you blame you blame them. You say, look, if these people hadn't committed a crime, they wouldn't be cooked to death. I mean, what they think? They think going to prison was going to the Ritz. It's like, you can't stand the heat, don't go to jail. That's what they're going to do. And so we're going to normalize suffering. We're not going to adapt. We're simply going to blame people. And let me be clear, you guys are next. If a big hurricane, knock on wood, hopefully it doesn't hit Louisiana, but it's an inevitability, and you guys get damaged, some city in Louisiana gets damaged, do you think the federal government, as it's sort of now comprised, come and say, don't worry, we'll help you, we'll get things back? No, it's like, you're living in Louisiana, what did you expect? Of course you got destroyed by a hurricane. I mean, it's like, why didn't you move? Why didn't you have insurance? You're going to be blamed when you're destroyed by a hurricane. And there are lots of examples of this, which in the interest of time, I will not do. So this is a plot I will just go through very quickly. Basically, we still control what world we live in. So the plot I showed you before is this business as usual plot. That's kind of what we're on track for. But if we're smart and lucky, we could get much less warming. If we're unlucky or dumb, we'll get more. And if we're unlucky and dumb, we'll get even more. And so we still control what kind of world we live in. And the reason is that, believe it or not, we are living through an energy revolution. And it's an energy revolution that's based on the fact that wind and solar are now the cheapest energy sources that we have. Now, a lot of people dispute that when I say that. I've gotten lots of talks. They say, no, that can't be right. Solar and wind are very expensive. And I say, well, let's look at the data. So let me show you a plot. The y-axis here is gigawatts of generating capacity in the ERCOT queue. So ERCOT is the Electric Reliability Council of Texas. They run the Texas grid, and they publish statistics on what kind of power energy developers want to hook up to the grid. And this is what it looks like. Solar, 43%. Batteries, 42%. Wind, 9%. Natural gas, 5%. So why is this? Now, these people are not, these are Texas energy developers. They're not Birkenstock wearing hippies driving around in a VW microbus. They want to make money. And the way you make money is with solar. Solar is the cheapest energy. It's probably the cheapest energy that's ever existed in humanity. And so you hook it up to the grid. and you make a lot of money. And that's why they're doing it. Batteries are also like minting money. You charge batteries in the middle of the day when power is cheap, and you sell it right after sundown when power is expensive. You're just turning a crank and you're cranking out money. Natural gas, not cheap. Nobody wants to build natural gas. Let me just give you a few other fun facts. In 2024, clean energy was over 40% of global electricity. We haven't seen those numbers since the 1940s. That's mainly due to the growth of solar. March 2025 was the first month fossil fuels in the US were less than 50%. Again, it's the growth of wind and solar mainly. Solar energy doubled in the last 2 years. It's now 7% of global electricity. And again, if you follow it out, I always like to put the numbers because people don't understand what doubling, the power of doubling. If you follow this out, it'll be half the power in 2031. Now, maybe it won't continue to double every 2 years, but maybe it will at the rate China is building this stuff out. And in Texas, again, wind and solar are the cheapest energy we have. And as Texas builds more renewable energy, people save money. Renewables save the average residential household about $200 per year over the past 5 years. Now, again, we're living through a revolution. Now, before people stop and say, but wait, I heard that the sun goes down at night. Yes, that is correct. So let's imagine. So let me explain to you how a modern grid that runs mainly on wind and solar still generates cheap, reliable energy. So let's do a thought experiment, a Donkin experiment, if you will. And imagine you need to generate a gigawatt of power, just for some reason, data farm, Bitcoin mining, take your pick. So there are two alternative grids that we could imagine. So the grid on the left is just 1 gigawatt of natural gas. You need to generate we need to generate a gigawatt of power. Let's just build a gigawatt worth of natural gas and let's just run it all the time. So that's one way you could do it. So the other way you could do it is you could build 1 gigawatt of natural gas and a lot of wind and solar. You can also do that. Now, does anybody think that's the one on the right is the cheaper grid of energy? Raise your hand if you think that's cheaper.
Which one?
This one.
Yeah.
Anyone think this is going to give you cheaper energy? All right, very good. So a few people got that right. So let me explain to you why this is a cheaper grid. So when you build natural gas and you generate electricity natural gas, you've got to buy natural gas. And if all you have is a gigawatt of natural gas plants, you have to buy a lot of natural gas over, say, the lifetime of the plant. We're talking 25 years, 30 years. A lot of natural gas. Natural gas is not cheap. Now, in this grid over here on the side, anytime the wind and the sun are available, you're using them. And that's essentially free. Once you build it, it's free. The marginal cost is zero. And that means on this grid, on this side on the right, you're buying much less natural gas. Because anytime the sun and the wind are out, you're not buying natural gas. You're just using the free power from nature. And when they're not available, then you run natural gas. But you buy a lot less. And it turns out that over the lifetime of this grid, say 30 years, you save so much money not buying natural gas that it pays for the renewable energy and you have money left over. So it actually saves. It is both a cleaner and a cheaper grid. And so you can imagine we can build a 90% clean grid today that basically build a lot of wind and solar, and that produces most of the power you need, but you maintain the natural gas infrastructure. So we have natural gas, you just maintain it. You just say, we're going to pay you to sit there and run anytime the wind and the sun aren't available. And you will pay for a 90% clean grid, you'll pay about the same you're paying for electricity today. Okay. And the economy will be better off because of externalities. So so in the last 30 seconds, let me just explain why we're not doing this already. So oil and gas, fossil fuel interests are a multi-trillion-dollar a year business. The idea that they would ever say, okay, wind and solar, you beat us, let's liquidate our companies, was always ridiculous. So they are using the power of warehouses of money to pay politicians to write laws that disadvantage renewables. You can see this going on in the Texas legislature right now. You can see it going on in the White House. The top one is Trump's wind power restrictions put blue states' climate goals out of reach. So he basically banned offshore wind. And then he signs an executive order to help dying US coal industry. Again, this is just the response to special interests. Society is worse off for this, but the special interests are better off. And so it's really solving this problem is really it's a problem of solving democracy. So I'll just sort of conclude. So adaptation is going to be very difficult, and we want to minimize how much we need to adapt to. We have the technology to largely stabilize the climate in the next few decades. So that's the positive message. I want everyone to understand this is a solvable problem. But the main challenge is overcoming the political problem. If we don't do this, the US isn't going to get left behind because China and India and countries like that are not going to stop building renewable power. And if we're still using expensive, dirty fossil fuels, we're not going to be economically competitive. That's it. Thank you.
Professor Burgess.
Thanks, everybody. I was being called. So until Canada becomes the 51st state, I'm going to use Celsius. This is. I don't think this is the PDF? I don't think this is the.
Try it.
Okay, there we go. No, you're fine. It was great. I like to show this picture because it's Wyoming, which is where I live currently. And I often think in the context of polarization, how can a country this beautiful be so polarized? I really think this is a beautiful country. So I want to offer 4 provocations that I think will become progressively more provocative from the perspective of this conversation. So the first is that the energy transition is underway, yes, but it's slow. We're not going to get to 2050, partly to net zero by 2050, partly because we can't build things, as Professor Dessler pointed out. As he also pointed out in Fahrenheit, we're on pace for roughly 2 to 3 degrees C warming by 2100. So this is global primary energy by source. And we are indeed having exponential growth in renewables. That's at the very bottom, but we also globally primarily rely on oil, coal, and gas. And if you think that's going to go to 0 by 2050, consider that we'd be lucky to have high-speed rail connecting Los Angeles and San Francisco by 2050, because we can't build things. This is where we're headed under in temperature. This is from Zeke Housefather, who co-authors the Climate Brink Substack with Professor Dessler. And so under current policies, we're maybe in the 2.5 to 3 degrees, maybe a little bit more if we get unlucky with the climate. If we do more, we're closer to 2 degrees, but that's kind of roughly where we're headed. Okay. Here's a provocation for both sides. If you think that Kamala Harris was going to get us to net zero by 2050, or if you think that President Trump is going to get us to drill, baby, drill and save clean coal, you're probably both wrong. So this is US emissions on the left over the last 4 administrations, including Trump 1. There's basically a linear 1.1% decline rate per year. The blue line on the bottom is a model of what would happen if Biden's policies had been implemented perfectly and there were no construction frictions and other kinds of market frictions that stop things from getting built. The red line is what happens if Trump undoes everything that Biden put into place. And then the dashed blue line, which you'd have to squint to see how it's different from the red line, is what happens if Biden's policies work perfectly, but we don't build power lines faster. So the point being, the president's not making a big difference in terms of emissions. And a lot of that has to do with the fact that the progress in renewables and what's going on in oil and gas, a lot of that exists in the market, as Professor Dessler pointed out. It exists to some extent at the state level, and it exists in global and interconnected, across states and across the world energy markets. The middle is clean energy investment. You can see a little bit of an uptick in the second half of the Biden administration from the Inflation Reduction Act and his other policies. But again, there was already an increase going on in the first Trump administration because a lot of the actions in the private sector. Texas is the biggest renewable producing state in the country. And then Obama and Trump and Biden were all good presidencies for the oil and gas industry and bad presidencies for the coal industry, again, largely for market reasons. Okay, standards of living will probably continue to rise for most of the world this century. This is a plot of damages from different types of natural disasters. They have cold related and not heat related, but they have a similar plot for death, which does have heat related. Cold tends to damage infrastructure more than heat. Interestingly, it also causes more death than heat historically. And then, so the rows are different disasters. The columns are different radii, how close or how far you are from the disaster epicenter. And the point is that all the lines are going down. The global average is about a factor of 5 since the late 80s. So the damage as a percentage of GDP has gone down by about 4/5 since 1980. And in low and middle income countries in green, it's gone down faster than in high and high middle income countries. And that has to do with basically that it's strongly related to GDP per capita growth, which in all but the poorest countries is faster in low and middle income countries than it is in rich countries. So we are adapting at a global scale. And in fact, migration, most of the world's migration happens within countries. So no matter what our border policy is, it's not clear to me at all that migration, isn't an option. Okay. Damage estimates. These are estimates of the different red dots. It's kind of hard to see the green line, but basically the red dots are estimates in the economics literature of how much damage you have as a percentage of GDP under different temperatures. And even these counterfactuals are a little bit interesting because they assume that, they compare to a world where everything else is the same except for climate change. But if the main thing causing climate change is our energy, and our energy is the base of the economy, it's actually kind of a strange counterfactual that we'd be able to get rid of climate change without changing our energy cost. But even if you take that for granted, and then I've shaded in 2 to 3 degrees Celsius, you see that the types of damage that have been projected are maybe something in, at worst, the order of 10 to 15% of global GDP, maybe 2 to 3 times higher than that, concentrated in some regions. And again, in the most pessimistic models, much less in other models. If you look on the right, this is how much damage different economic growth forecasts you would have to undo the growth. Because again, you're comparing, when you say, 10% GDP loss, that's compared to the counterfactual with no climate change. That's not compared to today. And the point is that in basically all of the scenarios, they're projecting much more growth than this damage would offset. But again, it's a strange counterfactual, because if you take the same economic models that produce these damage estimates, and you ask, what is the social cost of carbon? Basically, what is the price of the carbon externality that these models imply? And then you ask, okay, if that was the only side of the ledger that matters, then it would be socially optimal to apply a global carbon tax at that level. And so what I'm doing here is I'm taking estimates of the social cost of carbon from various models. The top one is the one that was used by the Biden administration. And I'm asking, what would happen to coal and oil prices globally if we applied that social cost of carbon per ton coal or per barrel? And you can see you have huge increases in energy prices. Coal, which is more than half of energy in China, goes up by almost a factor of 5 if we applied the Biden's carbon price globally. And I would guess that's not going to be welfare improving. In fact, if you take a recent IMF World Energy Outlook, World Economic Outlook, WIEA is the World Energy Outlook, they estimate that a 10% increase in oil prices reduces global growth by 0.1 to 0.2%. So ask yourself what happens if you increase energy prices significantly more dramatically than that. The point is not that we shouldn't do things, including the things that are already cheaper than free, right? There's lots of things that we can do to mitigate climate change that benefit the economy. The point is that even these estimates, which are not enough damage to reverse global growth, are probably only looking at one side of the ledger, where the other side of the ledger is very important. If you look through history, this is life expectancy in different regions. You could show a similar plot of GDP per capita, on a log scale. And the post-industrial economy is quite resilient. It's a lot more resilient than people think. So there's two big blips there in life expectancy. One is COVID-19, and one is Mao's Great Leap Forward, which caused the Great Chinese Famine, which was basically communism. Probably by the numbers, the single deadliest thing anyone's ever done to each other. So the point is, even that's just a blip in terms of the graph. So the industrial economy is a really precious thing, and we should be cautious about any notion of throwing it away, especially for anything that sounds like communism, right? Which to be clear, I don't think is the position of anyone in this panel, but is sometimes something you hear in the discourse. And then lastly, this is probably the most provocative thing that I'm going to say in terms of this panel, but I think adaptation will probably play a larger role than mitigation in ensuring that our standards of living continue to rise. And I think there's basically two reasons for that. And the first is that no matter what we do, we still might get unlucky. So what this plot is showing is basically, the temperature that we have next year is not a function of this year's emissions. It's a function of, every year before this emissions plus what El Nino is. So, internal climate variability. And then we have some uncertainty in how much our emissions warm the climate. That's called climate uncertainty. And then we have emissions uncertainty. How much are we going to emit? And the point is the further and further out you go, the more the uncertainty becomes, dominated by variability, and then climate uncertainty, and eventually emissions uncertainty, right? If you keep extending out to 2300, it's mostly emissions uncertainty. But out to 2100, now that we've ruled out some of the hotter scenarios and some of the colder scenarios, just in terms of what's happened, we're actually, most of our uncertainty now comes from climate uncertainty and internal variability. Again, that doesn't mean that our emissions don't matter and we shouldn't do something about it, but it does mean that a lot of how hot we are in the next century isn't just determined by our emissions. So we're going to need to adapt no matter what we do. Secondly, as an economist, I see a lot of advantageous incentives for adaptation compared to mitigation, right? So one of the challenges economically of mitigation is you have concentrated costs and diffuse benefits. Again, except in the cases where it's already cheaper and we should do those things. With adaptation, you have benefits that are more geographically matched to costs. So it's going to be easier to get people to do them. You have benefits more temporally matched to costs, right? I build better housing and I'm more insulated against hurricanes tomorrow, as opposed to I change the grid and then that's going to be really good for me, 50 years from now. There's strong market signals. So the things like housing prices, for example, there are some areas that are becoming more and more difficult to live in, and the housing market and the insurance markets are sending signals to move. Now, that's not good for those people, and we should make sure that we have good social safety net programs to help those people, but that is an example of markets facilitating climate adaptation. And then lastly, we have technology and trade, at least for now, and those things can again allow markets to find good solutions. Okay, and then lastly, just to drive home the point about how resilient economies are, I had a grad student of mine, Finbar Curtin, collect every example he could find of a major economic contraction, where we define that as either 10% of cumulative GDP per capita or more was lost, or it took 10 years or more to get back to where you were before the crisis. And most of them were not environmental. And the ones that were environmental, in every single case, had severe comorbidities. It was almost always a very poor ag-dependent country with coincident economic problems and poor governance. And these are the places that we need to worry about going forward. Because some of them are, like Madagascar, might be having its first the first ever climate-induced famine. But infrastructure, development, capital, and governance are the biggest needs, right? In some of these countries, it's not climate change that's their biggest problem. It's also not cheap energy that's the biggest problem. It's bad governance. And so we should be doing whatever we can with whatever source of energy we can to help those countries develop and build infrastructure. Okay, so these are my main points. And thank you, and I look forward to the discussion.
Very good, gentlemen. Questions for each other? You have a mic there, and if you want to sit, if you want to stand and come up and do your slide, then that's fine too.
Sure. I've got a question. So one of the things that I agree with that you said was that the energy transition is slow. And I guess the question is, why do you think it's slow?
Well, I think globally it's slow because it's such a monumental task, right? We're talking about changing every aspect of society. And I think that there's something to be said for working within the systems that we have to do that. So one of the things I used to ask my students in environmental studies is, which do you think is faster? Changing the whole world's energy system and food system, or breaking down the global economic and political order, rebuilding it up again in a utopian image, and then changing the whole energy and food system, right? And most people say the first one. And then the second thing, I think there's a lot of countries, we're definitely one of them, as you pointed out. We're just not good at building things. We're not good at building, renewables fast enough. We're not good at building trains. We're not good at building seawalls. And I think there's actually a potential for bipartisanship there where, both parties like to cut red tape, at least for the things that they like. And so let's cut red tape and let's let the market, keep doing what it's doing in some, for example, these renewable energy areas.
Yeah, just to comment on that, I think that when you say the renewable energy transition is slow, I think that's right in the sense that, as you showed that plot, we're still increasing the amount of coal and oil and stuff like that. On the other hand, China is building an enormous amount of solar energy. They're building almost a gigawatt a day. I mean, think about that, a gigawatt a day. A gigawatt's like a coal-fired power plant. Every day they build like 270 gigawatts. So it's not 3/4 of a gigawatt, but still that's unbelievably fast. And it's if the rest of the world joined in, we could do this. I think that a gigawatt a day gives you over 30 years, 10 terawatts. So that's a big chunk of the power we need. And so I think it is possible. It is going slow. I agree with that. I think it is possible for us to do it faster. And everything that's happening in the US at least is trying to slow us down. And I mean, if I were a college student, I would be furious at Washington because I mean, they are playing politics with your future. I mean, you are going to live through this. I cannot emphasize that enough. If we don't do the right thing now, you're going to pay the price. So I think this is a solvable problem. I can ask you another question, or do you want to ask me a question?
Can we just riff on this a little bit? Yeah,
absolutely. Yeah.
So, yeah, a couple things. I mean, one, absolutely, we need to build everything faster, right? So I think whether you're on the right or the left, some things like permitting reform are your friend. I also think, which may be a friendly point, that we have, when you're talking about paying a cost to solve global climate change, you have this tragedy of the commons, right? But when you're talking about innovation and technology, it's kind of the opposite, right? Whoever figures out the technology first gets to export it to everybody. Yeah. So I think that there's a really strong case for, dare I say, American greatness to continue to invest in these technologies. And I actually think that in my other world of studying polarization and climate change, there's a lot more down ballot support for that kind of innovation, particularly combined with cutting red tape than people think. Now, the one area where I'm going to push a little bit, I don't know if I'm pushing back or I'm just pushing in a different direction, is I'm really concerned about mental health of young people. And I don't think we should be scaring you. Particularly if you live in this country. Statistically, you're far more likely to be killed by mental illness as a young person in America than by climate change. And so I really think, now, if there's a threat, there's a threat. We shouldn't be coddling you either, right? But But I really think that it's important for you young people to take to heart the idea that it's much, much, much more likely than not that your lives are going to be better than your parents' lives, even though just like your parents, just like your grandparents, you're going to face challenges, and climate change is one of them.
Yeah, so look, I'm not here to scare anybody, but I am here to say that we can rebuild our energy infrastructure at basically no cost. I mean, in fact, it'll be a better economy. It'll be a better economy if we largely, not completely, largely switch over to renewable energy. You won't pay any more on your bill, and all the externalities of fossil fuels, you will be saving money. So you'll have a better economy. So this is something we should be doing. And the alternative is, there are some bad options out there. I mean, there are some bad scenarios for climate change. Again, there are people right now, I'm not scaring people, this is the truth. There are people who are going broke because they can't afford their homeowner's insurance. All right. How many people here own a house? Anybody? How many has people had trouble with their insurance getting canceled, their insurance rates going up? Louisiana.
They're going up.
Yeah, Louisiana is one of the ground zero places. I mean, this is already hurting people. I mean, you've got to realize that. And I don't want to, when I teach this, to be clear, I tell people this is a problem with a solution. The solution is to get the special interests out of politics. It's fossil fuel special interests that are really the root of this. Anytime you dig down into why, we're not building a solar array somewhere, we're not building a transmission line, there's greasy fossil fuel money at the bottom of that. There's research from Brown University about how they organized the opposition to offshore wind. It's all fossil fuel money and fossil fuel billionaires. I don't want to criticize the fossil fuel companies. I actually think Exxon, Shell, those guys are going to be fine regardless. But it's these billionaires. They're the ones who are really pushing back on this. And again, I would be furious if I were a student. I am furious. I'm not a student, but I certainly would be. And that's the thing. That's the thing we got to get. I mean, you've got, people have to realize that we have this opportunity, and we need to fight back against special interests. And that's really what it is.
Can I ask a question to follow up to that? So a couple things. One is regarding homeowners insurance. The temperature, even if we eliminated fossil fuels or let's say dramatically accelerated fossil fuels tomorrow, we would still have these problems, these adaptation challenges for several decades, including homeowners insurance. In fact, there's some adaptation economists that argue that the problem in the homeowners insurance market, the reason people are getting dropped is because state regulations, for example, in California, are not letting the insurance companies actuarially price the risk. And so they're leaving everybody high and dry when they could just be charging, the millionaires in the Hollywood Hills a lot more money, right? So there's an argument that for, less regulation in the insurance market, allowing markets to adapt better. But then regarding fossil fuels, it strikes me that, although it absolutely is true that there are special interests, including in fossil fuels, that are working against some of these things. I sometimes wonder if the climate discourse overestimates their power. It seems to me, that either we're having an unstoppable clean energy revolution that's cheaper, or fossil fuels are going to stop us, but not both. If you look through history, the Luddites never win. And if you look at the graph I showed with the emissions in the presidential administrations, I think it suggests that whatever's going on, it's not working. Even if the Trump administration stops, all solar and wind on federal lands, I think that's 4%. All offshore wind is less than 1%. So I guess what I'm saying is does, the Manichaean framing of, we should be angry at fossil fuels, I think has a grain of truth underneath it, but I wonder if it's constructive or if it's the whole story.
Yeah, so I guess I have, you asked two questions there, so I'll take this. First one's on insurance. So insurance is a very complicated system. So you have insurance companies that are regulated at the state level. They're buying insurance from reinsurance. Reinsurance companies insure the insurance companies, and you have all of these moving parts. And so there are lots of reasons why your insurance rates can go up because of inflation. It can go up for many reasons, but people have done studies, and you can look at the spatial pattern of insurance. In fact, I have a plot. I can show it if people are interested. You look at the spatial pattern of insurance, you can see that people pay higher insurance rates in virtually all states in places that are riskier for climate. So if you go to Florida, Louisiana, you guys, Texas on the Gulf Coast, up the Midwest, in the Midwest where they have a lot of severe convective storms. So we know that climate is driving up insurance costs. Okay, it is definitely costing people money. But, you know, again, because of the complexity of it, it's easy to try to distract people from like, well, you know, there are all these other things it could be, lawyers suing insurance companies, and all those things do play a role. But climate is definitely pushing people past the thresholds where they can afford insurance. At some point, if you can't afford insurance, what do? You can't get a mortgage for your house. You know, you can't sell your house because no one else will buy it because they can't get insurance either. As far as fossil fuels go, you know, I think, you know, I agree with what Dr. Burgess said in the sense that I think the renewable energy revolution is unstoppable. If you look at China, so China is set to basically dominate the world in everything. They're going to dominate the world in research because of US policies. They're going to dominate the world in energy. I'll just tell you a story. In 2007, I testified for the Texas House, and I said, we are at a crossroads, 2007, we're at a crossroads where we can either develop renewable energy that we can sell to the rest of the world, or we can buy it from, and I said California or France, because in 2007, they were mad about freedom fries. I don't know if anyone remembers that. So I thought France would get their dunder up. But they said, they didn't, they were debating a law to form a committee to consider climate and renewable energy, which they didn't pass. They're not even going to form a committee. And so that's exactly right. I mean, we have given China the energy, they have cornered the market in the energy of the 21st century, renewable energy. We let them do that. Absolute malpractice on our leaders' parts. And I do think it is unstoppable. What's going to happen is the US is going to get left behind because we're going to be the people who are using expensive and dirty and geopolitically destabilizing fossil fuels. One of the reasons China is pushing renewables so hard is not because they care about climate change. I think they do a little bit. It's because they understand how geopolitically destabilizing it is. They import all of their oil. What if there's a blockade? That would be really bad for them. So they are building the crap out of electric vehicles because that gets them off oil. So they understand this. And so I do think it's unstoppable. I think the US, though, we need to be world leaders on this. And that's where we're you know, Trump is going to do everything he can to slow it down around the world. Now, he can't stop it again, but, you know, I think that the US needs to be part of the solution here.
Sorry, can I ask him one more question?
We're going to do audience questions in about 10 minutes.
Okay, thanks.
Actually, about 2 minutes.
Oh, sorry.
Yeah.
So I actually wanted to ask you, so I was at a conference recently, which called the FIU Environment Forum, that is one of the most kind of politically diverse environment conferences that I know of. It's sort of, you know, there's lots that are just liberals, there's lots that are just conservatives, and this one has both. And one of the arguments, Florida International University. And one of the arguments that somebody put forward that I just want to hear your thoughts on is basically the same thing that you just said about China, except turned around, where they said, you know, China controls the key materials for solar, and the US is the biggest oil and gas exporter in the history of the world. And so as they argued it, from a national security perspective, that suggests that we shouldn't throw oil and gas out right away. It was an argument I hadn't heard before, still trying to decide what I think about it, but I'd love to hear what you think about it.
Sure. So that's a really interesting question. It does come up, this idea that, you know, China could embargo rare earth metals or things that go into batteries and magnets in wind turbines, things like that. The key thing to understand that there's an important difference between fossil fuels and renewable energy. And that is that in order to run your natural gas plant, you need natural gas every day. You need a constant flow of natural gas into your plant. If you ever turn it off, your plant stops. If you have a solar panel, you need those materials to build the solar panel. Once a solar panel is built, you don't need them anymore. They can't embargo the sun. And so there is a risk, In fact, I think we're seeing it right now. In response to Trump's tariffs, China is throttling back some minerals that it gives us, and it affects not just renewable energy, but also, integrated circuits and other things that are used like in car manufacturing. And so, it is an issue, but it's not the same scale of a problem. If you build an energy system that's running on renewable energy, you can't be boycotted. Now, they could make it harder for you to build more or replace equipment. That's a much slower scale problem than like when OPEC, anyone here remember OPEC embargo? Probably a few people old enough. I remember it. And, oil rationing. I mean, that was really bad. You don't want that to happen. And that's why China's going renewables. And they were smart. Again, they were smart enough to see this was the future. And I mean, I give a lot of really smart people there. They understand this is the future and they've worked hard. And the point I wanted to make during your talk, or one of the figures of your talk, is you showed how the investment was unconnected to the US administration. And in my mind, I was thinking that investment's connected to Chinese administration, because China made renewable energy so cheap through government policy that that's really what's driving the US. We should thank China for making this energy so cheap. They invested an enormous amount of money because they want to sell it to everybody.
Let's go to, let's go to
okay.
questions from the audience. Professor Jim.
I think I mentioned to you both that I was teaching a course in energy environment for 16 years in a co-op with Local based on that course. So I know a little bit about the topic. I'll make a couple of observations. China surpassed us in greenhouse gas emissions in 2008. They're now over 2.2 times, I think, the greenhouse gas emitters of all time in the world. Another observation, we're about 5% of the population of the Earth, maybe a little bit less. And we used to use 25% of the energy, and now that's dropped down to 18%. Another observation, about it's not all electrical energy. There's a lot more to our value than electrical energy. One of the biggest concerns I have is that 30% of the energy use in this country is based on liquid fossil fuels, gasoline, diesel, primarily. And that's 80% of that, 30% is that. And electricity is not going to supplant that very easily. Try electrifying an 18-wheeler, it's not going to be an easy task. There are some people trying it for sure. So I think there are a lot of concerns. One other is 40 years ago, renewables were about 18 to 20% of our total energy budget. That's about what they are now. Yes, renewables are increasing, but so are the use of other fuels. And then finally, the reason why we're doing so much better on greenhouse gas emissions than we used to is the transformation to natural gas use. We're dropping coal, not because of government regulation, not because of anything the oil companies are doing, but it's simply much more cheap than using other sources. Yep. That's a bunch of observations.
Can I?
Panelists, you want to respond?
Yeah, sure. So, great points. A couple of things. It's not just coal to gas. Efficiency, I think it's about a third. Efficiency is about a third, and renewables about a third, according to the EIA. But yeah, I guess what I would say, I mean, your point about non-electricity sources, I think is spot on. And what I would say is, government investments in R&D have about a 2.5 to 1 return, about a 2.5 multiplier. The more we develop technologies that are cheaper that can replace, like take trucks. I hope that we're funding R&D on how to make electrified trucks, but I'm not for forcing trucking companies to get them until we come with that technology. Again, making it easier to build things, I think, is good for whatever the market likes. And I think that Professor Dessler is right that over time the market is going to like cleaner and cleaner things. But certainly it's not there in every sector of the economy now. So I guess what I would say is a matter of your observations, I think are mostly spot on. And as a matter of policy, investing in R&D, getting better at building things, and letting the market do its thing elsewhere is a no regrets path forward.
Yeah, I mean, I guess I would add a few things to that. First of all, you're absolutely right. I talked a lot about electricity, but a lot of the energy we consume is not electricity. And some of it, international airline flights, we don't really know how to decarbonize that. So I think trucking is one, international airline flights. Most other things, though, we know how to decarbonize. Cars. I drove here in an electric car. Industrial heat. We know how to decarbonize that. You can use hydrogen or you can use electricity. I mean, there are ways to decarbonize just about everything. I think the last 10% of decarbonization, we don't know how to do that yet. But I would say that I've been in this a long time. I'm older than I look. I realize how my youthful countenance, I'm older than I look. I remember the ozone hole. I don't know if you guys remember that. I was actually doing my PhD on stratospheric photochemistry. I was studying the ozone hole. And I remember the people were making very similar arguments about phasing out fluorocarbons. Like, we don't know how to do it. You're gonna have to give up your air conditioner. You're gonna have to give up your refrigerator. It's gonna cause millions of people in Africa to die. We don't want to do it. And it turns out that once private industry realizes that the government is serious about getting rid of something, the innovations come. And again, just look at solar energy, how fast China got the price down. A factor of, they dropped 90% in 10 years. And with fluorocarbons, they went from, this is going to be so expensive. It's, you're going to have to give up all stuff. When they finally phased them out in, I think it's 1996, nobody noticed. Literally, it's like you got a car had new refrigerant in it, no one noticed it. So I am very optimistic that first of all, I know we can get a long way with existing technology. And I'm very optimistic about how clever people are, because if you just look at every problem that we've had, every environmental problem we've had in the past, people have solved it for far lower costs, acid rain, ozone hole, than people said beforehand. So I'm not worried. I think, the old joke about how do you eat an elephant, one fork at a time, you've got to start somewhere. We've got to start. If we sit around and say, this is really a hard problem, then you're sunk. So we've got to start, and we know how to start. We know how to start that will save money and will clean the environment, make our national security better, make the air cleaner. So we should do that. And once we're serious about doing that, I think the other problems will melt away. Maybe I'll be wrong. Maybe we'll get to some level of decarbonization that we can't get past. We'll cross that bridge when we get there. But I think we need to start now, because, we can do it. We can make the world a better place just with what we have now, and start on the problem, start going down the path.
Next up, did you want a quick follow-up?
Maritime, I would add about 3% of the energy used in the world is with shipping. And that's really important. I would note that one area of success in government regulation has had a big impact, and that's the cafe service. They have basically trebled the fleet mileage since 1965, and that's very impressive.
Explain what they are, cafe.
Cafe is the miles per gallon in your car.
Oh, okay.
Corporate average fuel efficiency. Yeah, so can I just say,
There was somewhere where
I will just let me just very quickly respond to that. About half of our shipping is to move fossil fuels. So if we get rid of fossil fuels, that shipping disappears. So
we're shipping coal to China.
Well, no, shipping oil. We are shipping some coal, but a lot of it's oil. And that's about half of our rail. We spend an amazing amount of energy getting fossil fuels, because you have to produce 100 million barrels a day of oil. And I think that's a savings that we get that we don't have to replace.
Good. Is there another question? I saw a few more over here. Yes, gentlemen.
I'd be interested to know both of your takes on carbon capture. It's a controversial thing.
Yeah, sure. So I have a very close relative who basically runs a company that's involved in carbon capture.
So you're disqualified from
I'm
answering.
right? I'm either qualified or disqualified. So yeah, I think that there's definitely some sources of greenhouse gas emissions that we don't currently know how to get rid of. Things like steel and cement, long distance aviation as two examples. And so I think it's definitely something that we should be doing. And there actually is, at least down ballot, bipartisan support for the incentives like 45Q. Oil companies support the incentives for carbon capture. And I think that's a good thing because as my close relative in the industry would say, voluntary carbon markets will never scale. Because basically, if you're not a government buying it for the public goods, you're a luxury buyer who wants to cut a bunch of ribbons and doesn't want to buy from any one project at scale. And if you're a group of institutional investors like State Street and BlackRock, that's going to put it's going to put pressure on companies to buy carbon credits. You're only going to ever get big enough to do that effectively by violating antitrust law, and so you're not going to be able to do that forever either. And so. All that to say, I think it's a promising technology, but definitely in many areas is still in its infancy. We know how to do point source capture pretty well. We know how to do storage in some places pretty well. We can do direct air capture economically if we're next to a huge geothermal vent like in Iceland, but otherwise not. So I would like to see lots of government investment in R&D. And again, I think this is something that historically, the oil and gas industry is supportive of too, at least recently. And I think I would like to see the government continue to subsidize it because it's a public good.
Other questions? Yes.
Did you want to?
Can I make a very quick response?
Sure.
So I think carbon capture is something that ultimately we need to do because, every ton of carbon dioxide we emit stays in the atmosphere for all intents and purposes forever, not literally, but for a very long time on sort of the human timescales we care about. So at some point, maybe later in the century, next century, we're gonna have to start pulling carbon out because we're gonna have put too much in the atmosphere. I don't think carbon capture is gonna be a frontline solution to the problem because there are cheaper alternatives. I think even nuclear is cheaper than carbon capture. And that's very expensive, but solar and wind are certainly cheaper. So you're better off just shutting down power plants and replacing them with something else that doesn't emit than having a coal-fired power plant and trying to capture the carbon. But again, I think ultimately it's something we've got to do just because in the next century, after we've decarbonized the grid already, we're gonna have to go through and clean up the atmosphere.
Sorry. You have the next question.
I'd like to push back on a couple of things. One is that I'm coming from industry. The industry I retired from is the leader in the carbon capture over in West Texas. And I have a lot more to say about that, but it's not where my focus is. The first is that I'm not going to dismiss out of hand or accept the fact that both liberals and conservatives agree that permits are bad or that we need to get rid of all permits. Liberals want to keep the answers that permits gather, but maybe get them faster. And if that's your position, I can go along with that. But I don't think we want to get rid of all permits, as we said. And I think that the link between mental illness and the fear over climate is a pretty tenuous link. You want to comment on either one of those?
Yeah, sure. I'll comment on both. So I guess working backwards, the link between mental illness and fear over climate specifically has not been directly established, although there is there's a survey that found 45% of young people say that climate anxiety affects their daily life and functioning, which is, far, far greater than the number of young people that are directly affected by the impacts. There is, however, quite a lot of evidence, and I would say growing body of evidence that the sort of catastrophist messages and mindsets that have been pushed over the last 10 years on a variety of issues by not all of the political left, but a segment of it, is linked to mental illness. So for example, the group with the highest rate of mental illness, diagnosed by a doctor is in a 2020 survey, 18 to 29-year-old female liberals with an over 50% rate, which I find scary. And again, as somebody with mental illness and that's touched my family tree and circle of friends, I take it very seriously. So your second question was about permits. Yeah, permitting reform is not about getting rid of all permits, right? Of course, we need, construction productivity is lower now than it was in the fifties, right? Some of that's bad, some of that's good. Workplace safety laws have gotten a lot better. Environmental laws have gotten better. You know, nobody that I know on either side wants to repeal the Clean Air Act or the Clean Water Act. But I mean, it takes almost 10 years to get a federal permit for an interstate power line now on average, right? That's not gonna get us to net zero, you know, anytime soon. And so there are a lot of inefficiencies in our permitting system, and permitting reform, again, I'm sure there's a version over here that says we won't do it ever, and a version over here that says get rid of all permits. But I think there's kind of an 80-20 position of let's pursue the goals of permitting that we have, but do so a lot smarter and a lot faster, like most other countries, maybe except the European Union, do.
Yeah, I'll just very quickly say, you know, I teach climate courses and I do talk to students. I've never done a study, but students come and talk to me and some of them are upset. And the thing I tell them is, don't be upset, get mad and do something about it because this is a solvable problem. So, you know, vote, get your friends to vote, go out and join an organization, right? You know, go work for a politician you like, you know, you got to channel it. But you're right. I think being unhappy, being upset is never the goal, is never my goal. My goal is to say, here's a situation, now do something. As far as permitting goes, I agree 100% with what Dr. Burgess said. You know, we don't build things in this country. You know, you go look at China, again, China is not a beacon of democracy. I wouldn't want to live there, but there are a lot of things about the country I admire. And, you know, their commitment to research, for example, I admire. And one of the things that they've done is they've built a really spectacular high-speed rail network that is really impressive. Now, the way they did it, you know, you can't just go and bulldoze a village and no due process. I mean, I don't know exactly what procedures in China are. We don't want to do that. But the fact that we can't build anything close to what they have indicates a real profound pathology. And, you know, so we've got to do something. And even if it means you build a natural gas pipeline, which is, you know, that's really the problem that, you know, the progressives support permitting reform as long as it doesn't allow the fossil fuel companies to build anything. It's like, that's not going to work. I mean, you know, so I do think that there's a lot of room to improve permitting, and that's really a key problem.
I've got a question here and I would love to recognize someone with a good bit less gray hair than me. And say students in university.
Fortunately, I'm not as old as them.
One of my things that I think about a lot that wasn't touched upon by either of you, that I think it'd be great to get some comments on, are how you think about how increased emissions and climate change increase the likelihood of low likelihood events, but ones that have very high impact. So I work with these sea level rise projections all the time, and so I agree with Dr. Burgess quite a bit with the idea that the most likely projection scenarios are something that we can probably adapt to. And I certainly agree with you on that. But one of the things that does get me very nervous is looking at the very the unlikely but still plausible scenarios associated with, for instance, like West Antarctic ice sheet collapse, which is going to become more probable in a greater temperature environment. And so I'm wondering, how are you thinking about that in terms of economic damages, for instance? Do those economic damage plots that you were representing earlier with GDP, do they account for things that are those extreme events that are still unlikely but more probable as a result of climate change? Because that's where I start to worry about risk a little bit more than kind of the traditional projections.
No, thanks for raising that. So a couple points. It's true that low likelihood, high impact events are important in stochastic decision making. There's a famous theorem from the economist Martin Weitzman. And tipping points are complicated because there's, you know, debates about, you know, what is a tipping point, when do they occur, how long do they take. Some climate economic models try to account for them, but I think, as with everything else in the climate economic models, there's huge uncertainty. One thing about the West Antarctic, I'm certain that the West Antarctic ice sheet collapse is not in economic models of 2100 because I think, and Professor Dessler can correct me if I'm wrong, the median estimate for how long that would take is 2,000 years. And so we don't have economic models that, go out that far. But maybe I'm getting out of my depth in the earth science here, so.
Yeah, I think that's a really interesting question about how do you make a decision under uncertainty? That's essentially what you're asking. So, for the Iraq War, for example, I think it was Dick Cheney said if there's a 1% chance that Iraq has a nuclear weapon, you have to treat it like a certainty. And that's a decision that turned out to be a terrible decision on the count of the US, in my opinion. I don't know if other people have different views of the Iraq War. And so, this is a real hard thing about how you do. I don't think there's a good scientific answer to that. That's really a policy argument. You have to have an argument with different stakeholders and things like that about how do you judge that. I do think, though, again, the fact that, I always keep coming back to this. I hope I don't sound like I'm just repeating myself. That, the fact that we can reduce the risk of, if it was very expensive to reduce the risk of that, it would be a really hard decision. But I think it's not that expensive to at least partially reduce the risk of that because renewable energy is so cheap that we can just start building it out and every ton of carbon you don't emit reduces the risk to some extent. It's really very hard to quantify. It's extremely hard to quantify that though, put a dollar figure, even a probability, because the models tend to be very linear. The climate model, the physical models tend to be very linear. They don't produce a lot of threshold behavior that is exactly what you're asking about.
Good. Other questions again? Okay, let me go to a student.
Dr. Burgess, I want to call back to sort of the damages as a percent GDP graphs that you showed. I do find hope in the rapid drop off.
This one?
Yes, that one. Specifically for the low middle income. However, my worry is that as climate change gets worse, you see increasing rates of severe climate instances, plus the sort of tendency of like insurance companies and the global wealthy to drop their concern for the low income. How do you reconcile sort of these damages and the impact that it will have on the global poor as there may be more consistent or more common extreme global events that will directly deal like the equator, which is for relatively low.
So, yeah, thanks for that question. So a couple of things. One, I'm not going to tell you not to worry about that. I think whether, climate change or not, there are lots of issues to worry about facing the global poor, and certainly climate change is one of them. Additionally, I would say, things like investing in R&D, investing in renewables where they're already cheaper are no regret solutions for the West, right? That help with those problems. I do think though, when you start to get into ideas of, at its extreme version, there's an idea that's quite popular in Europe of we should do degrowth in rich countries to decarbonize faster to benefit poor countries. And other things like that involve imposing huge costs, on our economy. I worry about even just from the perspective of the global poor, the economic interconnections. So again, besides the very poorest countries whose main impediment to growth is governance and cycles of conflict and things like that, low, middle, and middle income countries are growing faster than we are, partly because we're rich, right? And we're buying their stuff and we're helping them technologically leapfrog where we were when we were at their level of poverty. And so I don't think it's a straightforward, I don't think that's necessarily what you were claiming, but it's not a straightforward claim at all to argue that, if we made ourselves poorer to decarbonize faster, that would benefit the global South. I think, COVID is an example of where disruptions to supply chains for food and other things cause huge problems in terms of poverty and quality of life in those countries, which were otherwise, because of their young age distribution, much better equipped to adapt to COVID than we were, right? I think there's actually quite a strong metaphor there.
Let me get in. Oh, I'm sorry. Go ahead.
Yeah, I'll just respond very quickly. I do want to emphasize, I won't actually respond directly to your question, but I do want to emphasize something that Dr. Burgess said, which I agree with 100%. And that kind of points to your question, which is adaptation requires good governance. If you have people who aren't willing to, if you have a country where you're not willing to pay to air condition prisoners, it's like, what kind of governance is that? And I think that if we have to rely on smart, good governance, I'm skeptical. I'm a lot more skeptical of that than I am on the technology of renewable energy.
I see a question in the back from students, so let me go there and then.
So, should I introduce myself first?
Sure.
My name is Paul Yan. I'm a computer science and mathematics major here at LSU. So, second speaker, forgive me for forgetting your name, but I noticed that you were from Wyoming. And Wyoming, among other states, is a state which has had a pretty serious shift in how it is handling its energy in the last decade or so, with a lot of taking into resource extraction in the past that is now transitioning to renewable resources such as wind energy, especially since Wyoming is a windy state. I was interested in inquiring, what exactly do you think about that?
Yeah, so I'm really appreciative of the question. And I think this Wyoming illustrates perfectly how, if you kind of tune out the noise on the far end of both sides of the political spectrum, there's a lot of consensus. So we are the single reddest state in the country, right? I think President Trump won our state by over 40 points, I believe, in this election. And we have a Republican governor who supports all sources of energy, including coal, oil, and gas, but also including renewables, including carbon capture, including rare earths, including nuclear. He's a Republican. He's the fourth most popular governor of any state by approval rating, and he calls climate change an urgent problem, right? So I think he actually perfectly illustrates this, that there's a lot of common ground, below the extremes. Additionally, as an illustration of the interconnected market dynamics at play here, there was a bill passed by our state legislature, or sorry, not passed, proposed by our state legislature to remove requirements for carbon scrubbers from coal plants. And it either died in committee or died on the floor, partly because somebody pointed out that our coal, we export over 90% of our coal off into states that would like us to have those things. I'm really glad you allowed me to talk about my state, which I think is a good example of how there's a lot of momentum in all sectors for a common sense, all of the above for now approach.
Thank you.
Very good. Thank you. Gentlemen, thank you so much for your perspectives. I've got one question, sort of a follow-up on what our colleague down in the front row asked. And I guess I see a lot of opportunities, a lot of challenges in lower income and relatively energy poor countries, many of which are, I think, exposed to some of the dangers of climate change over the long run, with atypical intention. So Dr. Dessler, I'd appreciate hearing your thoughts on what are some of the opportunities for those countries in non-fossil energy growth. Dr. Burgess, I would also like to hear some of your thoughts on what are the ways that those countries can improve their governance such that we can use market mechanisms to encourage that kind of sustainable. Thank you.
Yeah, so every country has different renewable energy resources, different political systems, different levels of income. So there's no single answer I can give you other than to say there is one researcher at Stanford, Mark Jacobson, I don't know if you know him, who's put together a plan for every country in the world to get basically go carbon free. I think that let me tell you the story about Pakistan. I don't know if you guys know this. So Pakistan, they bought a bunch of coal-fired power plants that are basically bankrupting the country now because they signed a bad contract with China. And so everybody is buying. So China or Pakistan now, people are buying solar panels and just putting them on their house. And that's essentially how the country is responding. I think that the cheapest energy is renewable energy. And if you want to build a cheap grid, you still need some kind of dispatchable power if you want 24/7. So it's got to be some kind of natural gas, could be maybe small modular nuclear in the future, or batteries or something. But people say, well, they can't afford renewable energy. It's like, they can't afford fossil fuels either. I mean, it's like fossil fuels are no longer the cheap energy. I mean, natural gas plants, which used to be very cheap to build, are now actually getting quite expensive. There's a big backlog to buying them. Years delay to build natural gas. Solar, you can build a solar plant in a few months once you get the permits. The permitting's the problem. It's quick to build. So I do think that really is the future. I mean, it's some combination of renewable energy depending on the country.
Professor.
Yeah, go ahead. Just quickly respond. Yeah, it's a great question. There's certainly lots of examples of technological leapfrogging in the developing world. So there's lots of places in Africa that don't have landlines but have cell phones, right? I think in some solar microgrids is certainly something a lot of people are excited about in poorly connected regions. To your question about governance, I don't think there are easy answers. So I'm going to dodge the question a little bit, but what I will pivot to is saying to both ends of the political spectrum in this country and Canada and many others is we need to have more respect and appreciation for how historically rare and special our institutions are. And we shouldn't be cavalier in the way that I would say over the last 10 years I've seen on both sides about them. Because once institutions go bad, it's really hard to fix. Our societies are low entropy states. And the best things about our societies are historically unique. And the worst things about our societies are historically ubiquitous. So we should be spending more time learning about and teaching about in our schools how special and precious our system is.
Professor Delia promises a happy note for students, so maybe that will generate some more questions.
Yeah, Obama, Secretary of Energy, Nobel laureate Steve Chu, famously said the secret to this whole thing was developing carbon capture. And I don't think he's right, but I think there's something that's happening that's even more important right now. The Chinese battery company, CATL, I can't remember what the acronym stands for, that's their side, has developed a battery they released last year that's twice as good as previous. Tesla has also announced they have a non-lithium based aluminum battery they're coming out, which is double capacity. That means that electric cars will have ranges of over 600 miles, which will exceed what you can get on fossil fuels and which is easily attained a full day's drive. And they're supposed to be very fast charging as well. So I think there's a lot of good news on the technological side. And so we can't be just grim about this. I think students need to have hope. They need to understand that all is not.
Yeah, I gotta add one thing. So a student asked me this sort of like, what should I do? And I said batteries. I said, just like in the graduate, said classes, batteries. He looked at me. I said the graduate, the movie. I said,
the gray hairs, remember?
Yeah, it's like,
yes, right.
It's looked at me. He said Dustin Hoffman. He had no idea. So the cultural references were lost. But I agree 100%. The speed of technological innovation in batteries is astonishing. And I think we again, once you unleash the power of the market, innovation flourishes, and people understand that if they have a better battery, they're going to be rich.
Preach to both of you the power of the market and innovation. The only thing I would add to that is the back to the points about the Luddites never win. A colleague of mine has this study that I think is either out or will be out soon, looking at different effects of driving, willingness to buy electric vehicles. And if I'm remembering right, range anxiety ends up being by far more important than anything else. And I think this goes for a lot of, it's easy to say, it's easy to point to whatever the previous technology, incumbent technology is and say, oh, those are the bad people that are trying to wreck everything. And I don't think that's totally true. The industrial world was built on fossil fuels, regardless of what their future is, and has done a lot of good for humanity. But it's also just the case that I think people on both sides of the spectrum drastically overestimate the ability of bad actors to win the long game in a democratic system.
It does occur to me that if any of you know where there is an electric vehicle charging station, we do want Professor Dessler to get back. I'm not sure in Louisiana. I'm not kidding. I'm sure you found one
The hotel
already.
has one, yeah.
Now that you mentioned the 600 miles, I mean, he could have done it round trip if
That's
you
right.
had an aluminum battery, but not with, we have just another minute or two. I saw a couple hands of folks who haven't asked a question. Yes, go ahead.
Thank you both for your talk. I just had a small question. Kind of shifting from the perspective of gas and electricity. Two things that I saw this administration, President Trump doing, concerned me was the immediate expansion on the American timber production, which wanted to increase timber production by 25%, or the cutting the funding, or looking at cutting funding for research with NOAA. Would these two acts be concerning for the future of American environment at least, or would these be just blemishes in that graph you showed us previously?
Yeah, well, there's a very friendly country to the north that has a lot of lumber. But
Where are you from?
yeah, in all seriousness, I would say yes to everything you said, right? So as I mentioned before, federally funded research has an economic multiplier of 2.5 on average, in estimates I've seen. So regardless of what the effect is on emissions or oil or whatever it is, that's good fiscal policy to fund R&D, and we should keep doing that, certainly including NOAA. Our NOAA is not climate science. Obviously, NOAA is one of the crown jewels of the world, but it's not just climate. It's also things like weather, right? Which everybody understands how important that is. And even small improvements in weather forecasting can have enormous impact in things like lives lost in a hurricane, right? So NOAA pays for itself many times over. And I'm of course concerned about, now actually I have a slide. I don't think that it's going to be cut by Congress. So if you'll permit me, I'll just put this up. Okay, all these extra slides in case there are questions. So here we go. Okay. So what you're looking at in the middle is in gray, the White House budget requests for NOAA's OAR, which is where the climate science is. And then the black is the congressional appropriations. So there's a lot more down ballots. Basically, the White House requested roughly 50% cut in most of its years for federal climate science, and Congress said no, including when it was controlled by the GOP. So I think the battle for things like NOAA funding is going to be won and lost over, whether Congress asserts its control over the purse or not. But I don't think that there's as deep support for the kinds of cuts that have been reported in the media below the top of the ticket, so to speak.
Last word.
Yeah, I don't have a lot to add. I don't know a lot about lumber, so I won't, but the cuts to NOAA, and not just NOAA, DOE, NASA, I mean, these are, the US research is one of the things that's made America exceptional. It's the golden goose. It's driven all these economic benefits. And, when you give money to do research, you're buying the future. You're buying economic discoveries that you turn into AI and silicon chips and, all these other things. And we see what happens when you give them away to other countries. China now is the leader in renewable energy. And, we're going to hurt ourselves and we're diminish ourselves, and we're going to pay the price. So I think these cuts will be terrible. And I certainly hope Dr. Burgess is right that they don't actually go through.
Well, we've now come to the end of our time. I have to say that as a political scientist, I'm somewhat encouraged or maybe discouraged, because on the whole, they seem to agree that markets are good. They seem to agree that the climate issue can be brought under control, but it's the politics that's the real problem. So, you know, what's bad for the world is good for political science, we always say. So we'll see what we can do in the next so many years. Allow me to thank the folks at Bridge USA for putting, by the way, there's like a whole pizza left for everyone who's left in the room. So here, sorry on the live stream, we can't ship. But please, they can help themselves to pizza and drinks as well. Please take them. And please join me in thanking our panelists for this presentation. Finally, I think we do have, if you'll bear with us, if you were here at the beginning, you had the pre-survey and here's a post-survey. So if you dare take it, see if you can do it. That would be great. And thanks to all on the live stream. And you're here to talk for a few more minutes if you, if you would, sure. So people with questions, there might have been a few questions that that's fine.
Yeah, go for it.
Didn't get it.
I want to tell you both a story that you might enjoy. Back in the Gingrich Revolution, back in whatever, I was very active on the Hill. I was the director of Harold Sea Grant, so I was a big NOAA proponent. And I was at a hearing that involved all the brass. Jim Baker, the head of NOAA, was there. The chief of naval operations was there, all kinds of brass. Joe Friday was there from the Weather Service. And Representative Dick Chrysler gets up and he said, "We've got to abolish the National Weather Service." And I'll tell you why.
There's the app on his phone or something.
It's incredible. You know, the Doppler radar system is a year